meet you guys. Like you said, my name is Patrick Gryczka, Cloud Solution Architect at Microsoft. I actually used to attend NYU Poly back in 2011 or so. Yeah, I'm going to start off with basically just going into kind of cloud fundamentals and some of the details that go into Azure. And then we're going to move on a little to going into Azure DevOps and DevOps in the cloud. Just as a kind of raise of hands, how many of you guys have interacted with Azure or a different cloud provider and kind of deployed anything into the cloud so far? Okay, so we've got one. And in terms of people that haven't interacted, do any of you feel familiar with the cloud or kind of understand the basic concepts behind it? Okay, a little bit more. Cool. So if at any point this seems slow, or if there's anything you have additional questions on and want to dig into, just feel free to raise a hand, ask a question. Okay, so these actually, things that we'll go over, these actually line up pretty well with one of our basic certifications that we offer, an AZ 900, which for the most part is a little too low level to be for technical roles, but it's a great kind of starter for anyone that's kind of going for harder certifications. And it's also pretty common for business decision makers to take this just to show that they have a understanding of the core concepts. So really very quickly, we're going to go over the NIST definition of what cloud computing is and kind of what differentiates it from just regular kind of hosting companies. So before cloud computing, there were still hosting companies like Blue Gator and a couple of others that you could still basically go to them and on demand kind of decide, hey, I want to host this on one of your servers. Let's make it happen. Let's do it through the web. But really, the differentiating factors between one of those hosting services and what cloud computing really is come down to these different factors. So the first one is on-demand self-service. So the idea is that you, as a technical resource, can automatically kind of deploy whether you need a server, whether you need a kind of web app or some kind of platform as a service offering. You have the ability to, through the portal, immediately deploy that rather than having to go through a ticketing process where you create a ticket and send out a request to someone else. And so you're still kind of dealing with someone else actually executing that for you. Instead, you have it self-service. Next one is ubiquitous network access. The idea there being that you can do this basically from all around the world. You're not limited to these resources being tied to within, let's say, your corporate network or within even potentially a certain geographic region. You're able to basically make your applications available globally. Next one is location transparent resource pooling. So this is a big differentiating factor from previous hosting resources like HostGator. Mainly, it's specifying that all these regions, all these cloud providers like GCP, AWS, us at Azure, we all kind of pitch our however many 60, 90 regions all around the world, and we let you know exactly which locations these regions are in. We let you know not the exact address of the data center, but we'll let you know that this is East US, West US, South Central, Northern Europe, this is in Germany, et cetera, so that you can make the choice of hosting it in the place that best matches up with what your needs are. So if necessarily your app is going to be used most in Europe and you want to make sure they have low latency, you have the freedom to make that selection, and it's not obscured in any way where you're just kind of blankly saying, I want to deploy something, and you have no idea where it's going to end up being. Another one ends up being rapid elasticity. So just the ability to scale both up and down. So making sure that any resources you have, whether it's servers or whether it is these kinds of platform as a service instances and resource units you have, you're able to bring them up and down flexibly and usually through an API, so that once again, you're not limited by dealing with a customer service rep or just a technical person that's getting a ticket from you and then taking hours to respond. Self-service, you're able to use the API and initiate scaling up as soon as you realize you need it, and scaling down. And the last point is consumption-based. So another big change is that instead of like you would do with potentially a server farm. You instead of just paying for reserving a server for a year or a month, you're only being really charged for what you're using. So when you have a server up, you're being charged usually per second of actual time that you're using it. So as soon as you spin it down, you're no longer paying for it. I think for the most part we're up to sub-second latency for the actual consumption. But this is yeah, one of the really large benefits, especially when tied with the rapid elasticity. This is going to just really dig into everything once again. So one of the things that you get out of combining these different factors is you're able to guarantee high availability by being able to specify your app to run in different locations, because once again, one of these was location transparency. So you're able to choose, hey, I want to have my resources in this location in Europe. I want to have my app also running simultaneously in America, just to make sure that, God forbid, there's some kind of huge disaster, or maybe it's just common road work and somebody digs into a fiber cable and disconnects my data center in Europe. I still have something running in a different location, which I'm able to control, and I'm able to just guarantee high availability of my deployment. Scalability. So once again, the cloud for the most part offers pretty much unmatched scalability. You do have, of course, the option of trying to buy up servers and trying to spin up resources and basically lease land and build up your own data centers. But especially as kind of student developers, being able to just kind of go from zero to something and continuously scale that up, the cloud's kind of amazing for that. And we'll touch on things like serverless and other concepts that really kind of democratize software engineering, I think, and really make it so that anyone that has not just a good idea, but really an idea that is cost effective and is able to pay for itself, can basically start from zero and scale that up as quickly as kind of demand kind of pulls for it. Yeah, and you have different options in terms of the scalability. So for the most part, people tend to gravitate towards the horizontal scaling. The difference between horizontal and vertical being horizontal, if your application is running on a server, you're able to add additional servers to scale that out horizontally. Vertical scaling is instead, if your application is running on a single server, you're able to just basically choose a larger size for that server and scale up that way. So the main considerations here are just that with vertical scaling, you're usually dealing with some downtime, because as you're changing your instance size from, let's say, a small server to a medium server or a large server, you're just dealing with the fact that your application is shutting down for a couple of seconds and resetting. For a horizontal scaling solution, you're not dealing with that, but it does have considerations where if your application is built in such a manner that it's potentially stateful, where all the information is on that server instead of being in some separate data store, you won't really be able to take advantage of horizontal scaling unless you re-engineer your application, just because all of a sudden you're different. If this application is running on different servers, each of them is going to have different instances of this state data. So that's one reason people opt for vertical scaling, just because they don't want to deal with re-architecting their application and basically just actually putting the dev hours into it. But yeah, horizontal scaling for the most part is the winner if it's an option. Yeah.
This is a reason for moving towards REST APIs in order to enable horizontal scaling?
So I would say, to a degree. I mean, there are definitely options to not use REST APIs and still kind of pull data from an external source. But it's definitely one of those aspects where it's easier potentially if you're using some blob storage solution, whether it's ours or different cloud providers. It's definitely easier to just use that and pull the data in through a REST API rather than dealing with whatever network attached storage is going to have to deal with these different VMs. But it's not a given that you have to go in that direction. Okay. So another one is agility. So you've all probably talked about Agile and your different classes. but just the idea that you can, as you have these things that are on demand, you can just start kind of spinning things up and trying them without spending months and months planning ahead and kind of going through the process of pitching basically, these are the resources I need to try this proof of concept, and please give me the money to actually be able to fund this. Instead, if your team has a budget and you're able to kind of use that budget freely on Azure, you're able to easily spin these things up without as much approval and overhead as you would have. So you're able to jump directly into kind of this agile method where you're able to test things and kind of move forward and see where they basically see how things progress without basically delaying it with months of planning that might end up not being accurate based on just you not having any hands-on experience with these technologies. Additionally, you have fault tolerance and disaster recovery. So like I mentioned earlier, with high availability, just the ability to basically transparently put your application in different regions, and not just regions, even within regions, we give you the option to make use of availability zones. So within a single region, you'll have multiple data centers and multiple options for hosting your resources. So if there is a fault in, let's say, one data center, let's say all of a sudden, it's usually something that's network related, but if there is a problem and you're spread out across the multiple data centers using availability zones, your application can still be fault tolerant. And beyond that, you have disaster recovery options. And really, you can do a lot of these things. You can try to do them on your own, but the cloud just makes it so much easier because instead of having to pay for these additional resources that you might not really be getting the most out of, because really they're there for these disaster scenarios that might never occur. Having the on-demand nature of the cloud and being able to just spin these resources up as needed really gives you much more flexibility for these disaster recovery scenarios. So for the most part, there's three kinds of flavors for this kind of recovery. You've got a hot recovery site, which ends up being just a full-fledged kind of second copy of your site running the whole time. And this ends up being the most expensive, just because it in order to really function as a recovery site, it has to be able to handle the traffic that's going to hit it. It doesn't have to be double the size of your typical traffic because you're going to be able to scale it up, but it does have to still be a little bit substantive. The next one ends up being a warm recovery site, and this ends up being very similar to the hot recovery site. You're still running almost a fully functioning site. You've just scaled it down to the very minimum available in the secondary region. And the last one is cold recovery site. In this case, you're taking advantage of something along the lines of your infrastructure as code. So for us, that's ARM templates. And in an ARM template, you have specified all of the different servers you need to spin up. You have specified all the dependencies for how they're being spun up. And basically, as soon as one of your health checks fails for your main site, you're able to. Usually, you're going to want to have some kind of approval before you spin it up, just to not deal with spinning up an entire site without kind of just because of a faulty health check. But as soon as you have that approval that yes, my site is down, the cold recovery site is able to deploy from this template, and you're back up and running within a couple of minutes. Obviously, in this scenario, hot recovery is the most expensive, but typically you might actually want to have at least a warm recovery site if you have some kind of critical application, just because if you're dealing with a scenario where, let's say all of one region is down, that means everyone in that region with a disaster recovery plan is going to be trying to suddenly spin up resources in the other regions. So you're going to potentially deal with just potentially some kind of lack of resources, or just a little bit of a competition for the available resources. And for the most part, we like to think of the cloud as being kind of infinite resources at your disposal. But if you're suddenly dealing with literally a doubling of the consumption in a region, it's potentially going to lead to some slowdowns. So just having whether it's a hot recovery zone or even just a warm recovery zone ready, basically locks you in for having those resources reserved and just puts you in a much better position for actually scaling those resources up. Yeah.
This leads right to a question I had, and I don't want you to reveal anything proprietary here. So typically, amongst cloud providers, how much slack is there? Because we can scale up and scale down. If everyone in the world tried to scale up by a factor of 5, presumably the cloud providers themselves would run out of disk and CPUs.
I would say for the most part, it probably depends on region. For the most part, there's a significant amount, and there's enough that we want to be able to handle these kinds of scenarios. If a region goes down, we want to be able to handle everyone going there. And for the most part, this isn't saying that you're going to be rejected, that you're not going to be able to spin your resources up in that other region. It's just saying that dealing with all of this, you're going to start dealing even with situations of kind of network traffic and kind of limitations along those lines. So it's going to become an issue more so of kind of a delay for how quickly you're able to actually get your resources spun up there. And I think it's going to be more so a matter of time rather than you not being able to have your resources running there concurrently as someone else is. For the most part, we do have offerings that kind of support this excess resources that we have. So whether it's spot instances which other people have, or basically just this scenario where we have people bidding for this excess resources at much lower prices or whatever they're willing to offer for a given moment. We do kind of use that to make sure that we're able to support these additional resources, but for the most part, they're there. I would say it ends up just being a situation where sometimes not all regions are necessarily equal. I think you'll find that different cloud providers expand their regions where a lot of us have built our regions from the ground up and built new data centers. And there's even just cool side projects where Microsoft has been trying to build underwater data centers just because it checks off a couple of boxes where all of a sudden there's not as much worry that somebody's going to go underwater and tamper with anything security-wise, but additionally, it really handles one of the large issues of cooling, just kind of passively.
So you can be computing with the fishes.
Yeah, and they've had functional kind of demonstrations of single pods running, but that's not in production just yet. But basically what I was trying to get at is that while for a lot of these data centers, we build them from the ground up, there are a lot of companies that end up buying data centers, and I think we've bought a few as well, whether it's from IBM or some other providers, just as we're expanding, as they're kind of closing down their server farms, and we're kind of transitioning it to those. I would say those are potentially more at risk for potentially even just resource limitations, just because they're being repurposed from their existing designs. So yeah, I couldn't speak precisely to what the limitations would be, but I would think that those would be something that's kind of more in a transitional period than the ones that we've built from the ground up. Yeah?
Could switching the region be a considered option for this scenario?
Yeah, so I mean, in this scenario, you're basically dealing with you're launching these same things in a different region. For the most part, like the region, we're kind of working off the assumption that the region that your resources are in is down. There's no connectivity to it. It's whatever disaster happened. So at that point, that's why you want to have some kind of deployment template, some kind of template that basically is coding up your entire environment, and you're just spinning that up in a different region. Or like with the other options, just running a smaller copy in that other region, just in case. Okay, I think we're going to go into like 2 or 3 additional benefits. So economies of scale, basically cloud providers are able to buy in bulk and have different savings that they're able to pass on. And for the most part, the fact that we've got 3 main kind of competitors in the market is great for consumers, because it means that we're all competing on price. We're all trying to make sure that you guys have the best offer from us in order to come to us instead of someone else. So yeah, and in addition to even just having just the ability to buy, whether it's immense amounts of SSDs to furnish out these data centers. Additionally, there's just a lot of motivation for us to actually invest in the technology and build additional functionality and features. So one thing that we've done recently is, I guess two things. One is in a lot of our data centers, we've basically built our own kind of shim for these servers, where instead of dealing with Ethernet, it's now dealing with fiber optics. So we're basically just kind of working on maximizing the throughput for the communications that are going on within a single region between these servers, just to make sure that we're able to handle as much as possible. And I don't know if we would have necessarily had motivation to do that unless we were dealing with this kind of scale and basically kind of pushing for that. So you'll see the different cloud providers coming out with additional kind of technological innovations that are tying into all of this. Additionally, we're also doing a lot of work on software-defined networking, because that's kind of the underpinning of a lot of our offerings. And we've kind of touched on this as well, but really the difference ends up being between CapEx and OpEx. So capital expenditure is really when you're paying for something ahead of time. So if you're paying for a server for a year, that's a much higher kind of barrier for you to enter and start your business than it would be for you to just pay for however long it's running and then kind of pay as you go. That being said, we do offer options for CapEx where you can save a lot of money if you're willing to pay for some kind of instance, whether usually it's some specific family of VM. If you're willing to pay for a year or 3 years in advance, you're able to get usually about 40% in savings. And this is just touching more so, consumption-based models. Yeah.
Should we go back to the hot, warm, and cold slightly? It's just one factor I want to point out here. When we look at the cold recovery, right? What feature that we've talked about of DevOps do we need to be able to deploy here? We've got this undeployed, we've got this template, right? Yeah, but what's the infrastructure? Anyone know this? Infrastructure as code, right? Infrastructure as code. So this is a reason, amongst many. If you have to hand deploy at the point you're going to do the cold recovery, first of all, you're in a panic. Your site's down, you're going to make mistakes. Second of all, it's not going to happen automatically, right? It's going to take more time. You want to have the deployment of your site be fully automated itself, so when you have something like the need for a cold recovery, you don't have a sysadmin trying to remember what all the settings were that I need to configure the site. I just wanted to make that point since we were...
Yeah, absolutely. And we do offer kind of options for, so you tend to have two options with infrastructure as code on our platform. All right, there are definitely more than two. But the two ones I'm referring to are that you can basically start writing your scripts from scratch and just add resources as you want them to be added to your environment. But additionally, if you go even just through the Azure portal and start spinning up resources, each resource you spin up is actually going to have a template associated with it. So you can use that template as a starting point, or basically just take those templates and have them as your infrastructure as code and spin them up separately if you want to replicate your environment. And beyond that, there are other options where you can use things like HashiCorp has Terraform, which Terraform's an interesting subject just because it's their option for infrastructure as code, and a lot of people kind of like the idea when they first hear it because it sounds like it's going to be something that's kind of cloud agnostic, and it's kind of write your infrastructure once and all of a sudden you're able to run it in each cloud. But for the most part, you still have to know they basically have providers for every single cloud, and you still end up having to learn it the same way you would learn CloudFormation on AWS and ARM templates in Azure. So on the one hand, you do have a kind of a single format for these Terraform templates that you can use. On the other hand, there's a little bit of a delay for any new features and functionality where they'll implement it a few weeks or months after those new features come out for the individual cloud providers. That being said, they do have just options to basically make your life much easier, where with an ARM template, you're specifying each individual parameter that goes into a VM. You're specifying what NIC is it attached to. You have to actually create that NIC separately, while for the most part, a Terraform script will allow you to just create a VM, and in the background, it'll specify all the details for deploying all the resources that it depends on. Okay, so have you guys seen this before during your class? Not yet? Okay, so this is kind of going over the different levels of ownership that you get from different models. So when you're on premises, you're dealing with owning everything, all the way from the application down to the networking. It's your responsibility. As you shift over to something like IaaS, infrastructure as a service, which is whenever you spin up a VM with one of our cloud providers, that's what you're dealing with. So at that point, we're responsible for making sure the networking's working. We're responsible for making sure storage is set. We're responsible for running the actual servers and the virtualization. In the meantime, you're responsible for everything above that. So you're choosing what operating system you want to run, and also because we're not going to go into your VM and just basically mess with whatever computing environment you have, you're responsible for making any updates you would need to do to your operating system to make sure that it's still secure, and that any bugs that have come out, that you're patching for that. If you want to instead move on to platform as a service, we end up handling much more. We do handle the operating system, we handle the middleware and any runtime, and really you end up getting to just focus on your application and your data. That being said, a lot of people do still opt for infrastructure as a service, mainly because they do want the control that it offers them in terms of specifying operating system, in terms of really being able to have just that delineation of this is my VM, and I'm able to guarantee that I have this level of kind of isolation. And for platform as a service, we'll dig in a little bit to just kind of the benefits that there are for serverless options that fall into that. And finally, we have also software as a service. So software as a service ends up being things like Gmail, Hotmail, Office 365, anything where you're no longer responsible for any of the application code. You're just using the software as a service. And beyond just consumer options for that, we do have options where you're able to basically use software as a service for different options. Like I guess the line's a little blurry in terms of whether that falls under platform as a service or software as a service. But for the most part, we can offer Kafka instances through our Event Hub, and you are still bringing your own data. So I guess that'll be more platform. Okay. Okay, and this is just going into kind of more so what you would need to understand and take away from that to pass one of those 900 certifications. For the most part, they're really easy. If you study for like a day as a semi-technical person, you'll be fine for the 900. All the other certifications, like they'll require a little bit of investment of time, but that one's really meant more so for kind of like really a non-technical kind of project manager, or even let's say I don't want to say a CTO because they probably won't be bothered with taking a certification, but if you have potentially a lower level VP, they might be taking something along these lines just to show that they're kind of up on things. Okay, so cloud concepts, jumping into public, private, and hybrid cloud models. Really, the kind of idea for public, private, and hybrid is that when you're dealing with a private cloud, that really just means that people are running things on premises, or they're running them themselves. So they're not getting any of the benefits of just being able to kind of take advantage of this compute that's available on demand. The main limitations with public cloud are just that it is out of your control. You do have to end up trusting, whether it's Google, whether it's Amazon, whether it's Microsoft, you have to trust that they're running your resources well. And for the most part, we have a lot of incentive to do that, just because I would say for all of us, this is becoming our business. Whether you're looking at Microsoft or Amazon, we're all looking at this as the main portion of our business. This is where we're investing our money. This is where we're really investing our time and focus. So there's just no incentive for us to do anything but what's best for the customers that are using the cloud. I think Google's still a little bit more focused on the search, but I think they're also trying to push as far as they can into the cloud market. Okay, so really quickly, in terms of concepts that are going to be said here, so these are the regions I was mentioning earlier, where you can select any of these available ones to specify, I want my resources here. You'll see that there are kind of vast areas where we don't have regions yet, mainly because there hasn't been significant demand from those areas, but you can expect there to be an increase as those kind of areas kind of develop and build up a little bit more interest in these kinds of services. But for the most part, for any area where you see a lot of, whether it's e-commerce, whether it's just kind of data services, you'll see that in a lot of these areas, whether it's East Coast, West Coast, Europe, or China, we have built out a lot of resources for you to be able to take advantage of. And in addition to the regions themselves, we're building out points of presence that are more interspersed and more widely spread out. And the main difference between the regions and the points of presence is that the points of presence are basically areas where data ends up being cached, just to make sure that you're minimizing the latency as much as possible to your end users. And next we'll be going into a little bit of the scale of these individual data centers and regions. So over here, this is probably a little dark to read, but it says a data center buildings are about 1 football field in size. So that's large enough to hold 2 jumbo jets. And basically, there are 16 buildings per region. So that's up to 600,000 servers in each individual Azure region, and that just gives you kind of a sense of scale of each of those individual kind of 54 regions that are up. I guess as another note, you'll notice that for these individual regions, for the most part, these all function very similarly. However, there are times when you're required to basically have certain guidelines based on what country you're in. Mainly for Germany and for China, we've had requirements that those regions be managed by local providers and basically be built out locally. So you'll see that those end up being separate deployment options, where for the most part, if you're doing recovery or any kind of cross-region option, you'll be fine, but do just kind of take into consideration that those regions function differently, and they function differently because otherwise you wouldn't be able to take advantage of Azure in those regions, but they are kind of, to a degree, isolated and separate. Additionally, there's also US Gov and US Department of Defense regions, and those are also separate clouds isolated from the rest of Azure. And I guess as another note, in addition to just having regions, we also have probably first or second in the world in terms of amount of private fiber that we have available. So a lot of these regions, we connect with our own fiber instead of going through just publicly available fiber. So that means that we're not dealing with different amounts of traffic. It's all our customers that are paying for it. And basically that means that we're able to guarantee you a certain amount of throughput. We're able to guarantee that you're not dealing with as much noise from outside. And we're also able to guarantee that it's a much more secure connection. And increasingly, we're also working on services that are going to make that available to customers that want to use it. So in addition to just being able to choose which region you want things in, you're able to use services like Azure Front Door, which end up packaging in load balancing and caching and CDN functionality into into basically one service that you tie to your application. So that ends up handling other features like SSL offloading and anything that would be kind of just tied into really accessing your application. And yeah, these features end up, for the most part, simplifying your life, and really they're the underpinning for a lot of what we offer. So if you're hitting Xbox Live, or if you're hitting anything through O365, you're already kind of interacting with Front Door. And basically, we can't guarantee that there's 100% availability for these services, but we make sure to put our own services on them as well and kind of test them out before anything's released publicly, just to make sure you know that we're very invested. If anything goes down, we're in trouble as well. But yeah, moving on. Another point, regions end up being paired. So this is something that if you are looking to deal with disaster recovery, if you are looking to deal with kind of fault tolerance, you're going to want to kind of look at this and keep in mind what regions you're deploying to. Basically, we guarantee that of region pairs, at the very least one of a region pair will be within the first 50% to be spun up if, let's say, the entire world goes down and every region in the world goes down. This is something that never going to happen, not something that really is a realistic problem. But if you are doing a disaster recovery planning scenario and for whatever business you're working for, it is something you need to kind of keep in mind, that you do want to pay attention to what different regions you choose, just because if you don't choose two paired regions, you don't have a guarantee that one of those regions will be in the first 50% that gets spun up after a worldwide disaster. Okay, we touched on these a little bit earlier. So this is if your application doesn't necessarily need to survive a regional disaster. Let's say all your customers are in Europe, and really if Europe goes down, you're not going to get any benefit out of running things out of the US. Or even if it's just really a cost matter where it's just not financially responsible for you to deal with that kind of backup in a different region, you can look at availability zones. So basically within a single region, like you saw, there are multiple data centers. For the most part, data centers are built really close to each other, but you'll see that they're grouped into these availability zones, and there's typically between up to maybe 3 milliseconds of latency between them. So that basically allows them to communicate for the most part seamlessly, and you're able to select any of these and have basically fault tolerance across any kind of power, cooling, or network options. So we've had situations in the past where, let's say a data center gets struck by lightning and it happens to hit a certain cooling component. There have been times when data centers have literally caught fire, but thanks to features like availability zones, we've been able to, for the most part, almost entirely minimize any impact to customers. But this is something you can keep in mind just to make sure that you don't get impacted if you're already designed to work across these different availability zones. Beyond availability zones, as a kind of even lower level of tolerance, you're able to take advantage of fault domains and update domains. So fault domains end up being tied to singular instances of hardware. So if you're just dealing with, I don't want there to be an issue where if this server rack goes down, I'm facing trouble. Within that single availability zone, you're able to specify, okay, I want to have 3, 5 fault domains, so put my application on instances across these different servers, and you're basically secure from just a single hardware failure. Beyond the fault domains, you have update domains, and update domains you can look at as more along the lines of, this one shows it a little differently, but basically it's just a matter of you're updating one set of your instances at a time, so that if the code you're pushing is actually breaking everything, you don't break your entire site. You're instead getting these health reports from these servers, and you're able to roll it back. Okay. Beyond that, we have different resources for actually managing for managing your resources in Azure. So we've mentioned a few of them already. You have your REST clients for various APIs. You have the Azure portal. In addition, you have PowerShell and CLI as different basically command lines that you can use. But all of these tie into a single kind of resource management plane, which we call ARM, Azure Resource Manager, and that interacts with everything, whether it's virtual machines, web apps, or data stores. Yes?
How does the PowerShell interface differ from the command line interface?
So PowerShell's been around a little bit longer. I'd say some of us internally prefer it just because we've been using it for a little bit longer. That being said, the CLI is fully developed. I haven't seen anyone running into issues of it being not equivalent. We used to potentially maybe 2 years ago had an earlier version of the CLI that was lacking something, but at this point it's a new version. It should be completely equivalent, so you're able to run it off of Linux. Additionally, if you want to just test it out within the Azure portal, we do have a Cloud Shell where you can just run these commands in there instead of installing it locally, just if that ends up being a little bit more convenient as a way to test it out. Okay, I'm going to touch really quickly on the core products, and then we'll jump into more of the DevOps portion. So in terms of looking at Azure, there's a lot of different services you have available. I think we're not necessarily at 200, but we're above 100 in terms of available services. And these range from compute services like VMs, Kubernetes clusters. We have that container service is AKS, or Azure Kubernetes Service, which basically allows you to just run Kubernetes, and it basically just means that you get a free control plane that's basically managed by us to cut down a little bit of the difficulty of spinning things up. But beyond that, you'll see things spread from a CDN to API management. Over here in the application platform, you'll see web apps. Web apps end up being platform as a service where you can deploy your application code or containers, and that'll basically handle auto scaling for you, so you're not dealing with an individual VM, you're just dealing with your web app and basically putting how much you want it to scale up or down. Functions are basically our function as a service, which powers, for the most part, serverless implementations on our platform. And really there's a lot of different areas you can dig into. Additionally, we have cognitive services under intelligence, and that might be really cool for some of you guys to check out, especially for various projects you might be doing. The cognitive services end up just tying into pre-built machine learning models. So there's various ones. There's different voice services where you can basically use an API to transcribe any speech to text. You can also pull basically what someone's tone is saying about whether they're happy, sad, angry, etc. There's image services, so you can send an image in and get feedback on, is this a male, female, what's available in this picture, do they seem happy, do they seem not happy, etc. And additionally, we have custom image services. So if you find that the existing service doesn't kind of meet your needs, I think Etsy's local, and they're working with GCP at the moment, but they were finding that their just regular vision services weren't able to necessarily help them because they were dealing with just all those various products that are available on Etsy and aren't really widespread products. They're just this niche thing that there isn't necessarily many pictures of. But you can use a custom vision scenario where instead, if you upload different pictures of things you're trying to identify, whether it's let's say you've got this is one that's going to be covered by the regular vision, but I'll put it as an example anyway. You could put pictures of, let's say, various objects and pictures of specifically a bike. You'd be able to specify whether different directions, whatever along those lines. As long as you flag all of those pictures of bikes as bikes, the custom vision scenario will be able to identify that. Additionally, if instead you want to do something more complex, like is this made of wood or something? It should for the most part be able to handle that. Okay. Any general questions about kind of breadth of services or things you have used, have not used, might be interested in using? This is typically the response we get from customers when we show them a wall of 100 services, which is why I have a job, because as a cloud solution architect, they basically, whenever a customer wants to do a specific kind of project, they'll come to us and they'll ask us, what do we actually use from here, and how do we put it all together? So it's an interesting job, just because of these 100 services, they're also consistently changing. So it's something to kind of stay up on. But yeah, it's a great role if you're interested in kind of continuously learning. Okay, so this digs in a little bit to just specifically what the compute options are. And you'll see it's organized in a way that scales from IaaS to PaaS. So the lowest level, we have virtual machines, which is you're managing everything. A little bit above that is scale sets, where you still have basically control of your virtual machines. You're still putting in the image that you want to run, but you give us the option to basically handle scaling for you. So you specify the one image, and then within that scale set, we'll basically scale up and down within limitations that you preset, and just handle that aspect for you. Additionally, in addition to just the Azure Kubernetes service, we have our own container, not just container orchestrator, but also really a service mesh called Service Fabric. And Service Fabric will also let you run any containers you want to run. Additionally, it will allow you to run just any executable, so you don't even necessarily have to go through the process of containerization for that. In terms of usage, you'll probably still opt for Kubernetes, just because it's really the industry default at the moment. Only reason it might make sense to explore Service Fabric is if you're more interested in kind of just a little bit more control over having statefulness within your service mesh. So Azure Service Fabric currently is basically the underpinning for all of Azure. So it's able to handle that kind of scale, and it does have built-in data structures which will allow you to just have state stored. But yeah, it hasn't necessarily found much pull yet. Okay. These were the management tools. I think I'm gonna skip across this for the purpose of time and jump into Okay, so Azure DevOps. So before we dive into the product Azure DevOps, we'll also touch a little bit about how I guess as it says here, the evolution of application platforms. So initially, when you're on-prem, you're dealing with a lot of questions. You're dealing with really a lot of questions. You'll have a lot of, whether it's regulatory requirements or just functional requirements of how often do I need to patch my servers. If you are dealing with something like financial services, you're going to be dealing with, all right, where are my servers stored? Are they in a secure location? Have I installed cameras to actually keep track of everyone that's accessing these servers in case I get audited? Sure, there you go. Are my servers in a secure location? Can I dynamically configure the app? How often should I back up the servers? You're dealing with a lot, and it's almost like an entirely separate business where in addition to developing your application and focusing on really the value that you're bringing your customers, you're also dealing with this separate aspect of how do I maintain all of this infrastructure that's actually running my application. So as you go a step beyond that, and you're dealing with infrastructure as a service, instead of you being responsible for all of this, all of these questions kind of end up being a little bit more locked into whether it's the provider or whether it's you. So you end up instead dealing with, okay, I still have to deal with patching my servers because I'm still responsible for anything that's going on with the operating system, but I'm no longer as concerned about Where am I going to buy this hardware from? Do I have to maintain a relationship with this vendor to buy these new hard drives? These hard drives I'm running, they've been running for 2 years straight. Am I confident they're not going to fail? All of that ends up coming onto the cloud provider. And beyond that, of course, the security aspect also end up going to the cloud provider, where you're no longer worried who specifically is accessing the physical servers. Now you're just worried about who's actually accessing the servers through, whether it's RDP or SSH or whatever you're using to get into them. Beyond that, as you're jumping to platform as a service, now you're no longer dealing with that patching question. You're dealing with a little bit less, where now you're just like, am I able to scale my servers? How much do I actually need to scale it? How much do I actually need to do? Is it really sensible for me to scale above a certain point? And really, once again, you're able to focus more so on your application. And the final one ends up being, in my mind, serverless. Serverless lets you really focus on just how do I architect my app? What does my application actually have to do? And really, for the most part, a lot of the other questions end up not really being something you have to look at. Another big thing with serverless, I would say, is that because it's all just on demand, you really do have to worry about, is my function something that pays for itself? Is this application something that's going to really be cost effective? Because if it's not, you really do end up dealing with the fact that if this can infinitely scale and people just keep hitting your site, and once again it's not cost effective, you're going to be on the hook for all that consumption. Okay, and really quickly I'll just touch on two little more touches for serverless, and then we'll jump into DevOps. But really, one of the huge benefits for serverless is, once again, you can kind of just worry about, how does my application have to look? What functionality do I actually need? Instead of worrying about just the management of various VMs, of even managing how do I access these VMs with a jump box. Instead, each individual function has its own little function that's running. You're able to have API management as a service, so you're able to basically skip having a separate API server. Basically, you're just able to do much. I would say even much more with less, even though you can do absolutely the same with less. But really, this will give you far higher scalability than necessarily the previous architecture. Yeah.
I think there's something worth explaining in this context. Well, in any context, serverless doesn't mean there aren't servers. Of course, underneath you have to have actual servers at some level, but you're not dealing with them. You're not thinking about them in terms of your architecture.
Yeah, absolutely. It ends up being just an abstraction level of their servers, but I don't have to think about them. I don't have to really think about the work that's associated with them. I'm only focusing on this code that I'm running.
You don't need to think, I need 6 virtual machines.
Yeah.
For instance, I need this much availability.
And you're in a situation where you're no longer even dealing with, I have to run a server 24/7 just to make sure that my code gets run. Instead, every time you or your code gets run, every time someone hits that API endpoint and calls that function, that you're only paying for those couple of milliseconds that your code is actually running. So all of a sudden, let's say you're doing some kind of education technology app and you're dealing with, let's say, some kind of learning platform. Most of the time, kids aren't hitting the platform. When they're in school, they're probably not hitting it. When they're sleeping, they're probably not hitting it. So there's a lot of time when really usage is at 0. You're probably getting the most hits between 3 to 5. So having to maintain a server that's able to handle your peak basically usage, just 24/7, and even if you're able to take advantage a little bit of cloud scalability, you're just not able to scale down to 0 with a regular VM, because just to spin a VM up is going to be probably a process of a minute, a couple minutes, and even with a container you end up dealing with seconds, so it becomes a little bit more feasible. But really, you're not going to get the kind of instant from 0 scale up that you would with a function elsewhere. Okay, And this is just touching on basically the only thing that you're dealing with is code on a client can have basically you can have a lot of logic written into your, whether it's an HTML page or whatever, that ends up calling the individual API for any functionality. That API will just call any individual function that's being used in that point in time, and that function will just reach out to a data source depending on what's needed. So whether that ends up being a NoSQL database like Cosmos DB, or if it is just a regular SQL instance running somewhere, it just really simplifies basically the functionality of your application and what you have to think about. Okay, so now looking at Azure DevOps. So in general, I don't know, can one of you tell me what do you guys think DevOps is?
We're a couple months into the course, better have some sort of answer at this point. So look, you're gonna be out interviewing many of you soon, right? And you're gonna get asked questions like this. This is a good place to practice answering without a lot of pressure, right? So what's DevOps? Dennis, what's DevOps?
So we're trying to integrate development and operations, and we're trying to integrate them in a way that we're able to deploy without having so many problems as we used to have at some point in the past.
Okay, yeah, absolutely.
Anybody else? Give an offering? Peter?
Development or development operations is the methods that are used to develop a product and the process which we should approach it, and also how to deploy it.
Very good. Anyone else? All right.
Okay, great. Yeah, so I mean, one of the things that I don't have a video here, but there's a video that one of the main project managers for our Azure DevOps loves to show, and it's basically if you're looking at kind of the F1 cars and the pit crews that work on them, he loves to kind of show the original kind of like, this is still like a black and white video of people working on it, and it taking about a minute to go through the individual kind of like tire changes, refueling, and all of that aspects of them doing a pit stop. And then he likes to show them as well today, where today it's almost like under a second. Basically a car pulls in, everyone works together, takes the wheels off, puts new wheels on, refuels, and the car is out and ready to go. So what's the kind of purpose of that? It's just kind of a metaphor for how DevOps kind of changes everything. Instead of dealing with even though you're doing all these same tasks of deployment, of basically dealing with continuous integration, continuous deployment, just the fact that you're able to use a process, have people that kind of know what they're doing, and usually have some kind of product that really allows you to automate these steps. It allows you to get the same work done in a much quicker time, and it gives you a lot of benefits that range from kind of allowing you to do more agile development by being able to just continuously deploy and continuously test everything you're doing, rather than having to spend more time kind of planning for these kind of larger monolithic deployments. But overall, it's really about kind of optimizing your process. So over here, the way we describe it is DevOps is the union of people, process, and products to enable continuous delivery of value to your end users. And I'm going to be introducing you to the Azure DevOps product, but really you can't buy DevOps. You can absolutely get this product and incorporate it into your DevOps your DevOps process. But just having something called DevOps doesn't kind of solve that problem for a company. Really, you need this combination of these three things working together to make sure that you're able to achieve this cycle of continuous integration and deployment. And over here, yeah, you'll see it just kind of keeps being a cycle of build and test, deploy, operate, monitor and learn, plan and track, develop. And we'll dig in a little bit into how each of the services offered by Azure DevOps ends up allowing you to do these things. So what are the benefits that you get from this? Like I said, one of the benefits is really that it allows you to really go for these kind of more agile and lean methodologies. But really, there's financial benefits as well. You can get increased revenue because all of a sudden, if you're able to iterate quicker, it's just a huge plus if people are able to see that there's a benefit to kind of using your platform over another one and with constant updates. One thing you might see is something like basically what's the game that's popular right now? Fortnite. There you go. The main differentiating factor for that one is just the fact that they're able to knock out updates consistently, very consistently, and it just means people are intrigued. People are like, what's going to change next? And for the most part, no one else is able to. Correct me if I'm wrong. I might not be up on things. But no one else is able to kind of keep up with the same kind of pace of steadily putting these same updates in. And I don't know, even when potential competitors come out, is there someone else?
No, it's just there's another game that kind of like continuously updates too, like currently.
Tell me, please.
I think League of Legends, like they actually do like updates like every few weeks or so.
Okay, but they're in a different kind of vertical, right? Like in terms of what kind of game it is. Okay. All right. Touching back, so basically different numbers you have. Yeah, you're able to increase your deployment frequency. This says 46 times, but it's really just a change from, instead of dealing with, this is our one kind of weekly deployment, or like this is our one bi-weekly deployment where we're putting all these changes in. All of a sudden, if you're able to just put it all in as you're developing it, test it on the go and kind of see what's happening, you're able to just kind of iterate much more rapidly. And yeah, it all translates to faster time to market because you're not dealing with, once again, I've waited a week to see if my change works, it doesn't work, and now all of a sudden I have to kind of go from the top and try to figure this out. Instead, as you need to kind of test something, you're able to do it. Okay, so in terms of how we can help, so really the way we pitch our DevOps product is that it's flexible. We offer a variety of different services, but we don't require you to use them all. Basically, if you want to swap out our repos for something from GitHub, if you want to swap out our Kanban boards for something from Atlassian or some other provider, we're totally fine with that. We'll give you the option to just toggle those services off. Really, the idea is that we want our tools to fit into whatever kind of workflow you have and whatever needs you end up having. Additionally, yeah, we're open. You'll see that we offer functionality, so you can run agents for builds, whether it's Windows, Linux. You can even do Mac OS builds. So if potentially you're trying to deploy some kind of iOS app and you don't have necessarily a Mac at home, you can go ahead and create a free little Azure DevOps project and just build it on Mac OS over there. Okay, so what kind of technologies do you need to really support DevOps? This all kind of ends up pulling into the services that we're going to introduce in a second, so I'm tempted to just jump over. But basically, you need both continuous integration, you need your continuous deployment, and additionally, you need to be able to monitor and learn from these deployments and integrations that you're doing. So continuous integration just means that as you're actually writing code, you're able to have basically builds running and testing how is this code passing all the necessary tests? Is this actually functioning the way it's supposed to function within the context of the project as a whole? Moving on to continuous deployment, really it's just a matter of are we able to deploy to our environment as soon as changes have gone through testing, as soon as they've been approved. And that really just lets you start dealing with the new kind of baseline that you're working from. Okay, so in terms of the actual services that you'll see in Azure DevOps, you've got your Azure boards, which are Kanban boards. You've got Azure pipelines, which end up being pipelines that you're able to use to both do your builds and do your deployments. And the pipelines, I think, are really the meat of the offering, where they give you the opportunity to build out, whether it's a simple pipeline or a complex pipeline, just have automation built in. So as soon as there's any changes that happen to your repository, this is able to kind of pick up on the change and start implementing whether it's a build, whether it's even asking for someone to potentially approve your code for deployment. You have just a bunch of these different factors in there that allow you to build a pipeline that suits your needs. Beyond that, we do have Azure repos. You're able to get unlimited repos, and this was a more compelling offering before we ended up buying GitHub, just because we did have unlimited repos, private repos for you, where I think GitHub still had some limits that have gone away since then. Beyond that, there's really no need to use Azure repos. If you don't want to, you can absolutely just pull in GitHub, and it ends up working quite well with the platform. One thing to keep in mind is that if you're working with a company that is still using something along the lines of Team Foundation's version control, Azure repos does support that in addition to Git, so you're able to host that here without any trouble. Beyond that, there are test plans. So test plans allow you to really write out all the steps that are going to be necessary for any manual testing. And there's a little bit of automated testing, but for the most part, I think your automated testing can be almost built into your Azure pipelines. So Azure test plans ends up being a little bit more for orchestrating any manual tests that are going to occur throughout your Azure pipeline. So you can just build it out you can write out specifically what steps there are for testing in your test plan, and then usually you'll have some kind of a gate going on in your Azure pipeline. So as soon as the code passes a certain point, it reaches a gate where there's testing. Someone has to go through the steps of testing it, and then they'll click an approve or a deny when they get through that test, and then it'll move on to the next step in the pipeline. Next is Azure Artifacts. So Azure Artifacts is where you can store all of these various builds that you're creating. Additionally, you can store any dependencies that you have. So if there are certain packages that your code requires, and you want to make sure that you have that package, and just in case there's some change with the provider or anything along those lines, you can make sure that's all stored in your Azure Artifacts. Okay, I'm gonna jump out for I'll probably wait here for a little bit. But one of the really great benefits of Azure DevOps is that for the most part, for all of you, any projects you're working on which have, let's say, as long as you have less than 5 people, if it's a private project, you can work on it for free. You're gonna get to run about one agent at a time in terms of having concurrent jobs running, but you'll be able to basically have unlimited repos, use that one agent as basically unlimited as long as you're not scaling up to multiple agents for free. And as long as you don't go above that 5-person limit, the moment you go above that 5-person limit, you end up dealing with just paying for a per user licensing cost. Additionally, if you do need to scale up the amount of agents you have to be able to run these jobs, at that point you would need to pay for an additional fee I think it's a monthly fee for the agent. But you do get the one hosted agent, and you also get one I think on-premises agent. So if you wanted to have your own server kind of running something, this could trigger that server to be able to, whether it's run builds or whatever necessarily you might need. Okay, but digging into this, basically the idea is that this will allow you to really power any DevOps solution you need. whatever kind of language, whatever kind of platform, whatever kind of cloud you want to run something on, Azure Pipelines is going to be able to help you basically build for it and also deploy it. So that means that we're not limited to basically our own services. It's not limited to you trying to run things on Azure. Like I said, you could have your own on-premises agent. So you can have just a server running builds locally, and this will trigger it for you. You can have a server in AWS. You can have a server in GCP, wherever you necessarily want it. As long as communication is enabled, you'll be able to trigger that from here. Additionally, we do pride ourselves on being able to basically build any kind of language, any kind of platform that you're looking to do. So if you find something that doesn't work, for the most part, the main guy behind this, Donovan Brown, he tends to pretty quickly jump up to make sure that it's supported. That being said, I don't think you'll find anything too easily. Beyond this, it's extensible. You have support for doing any kind of DevOps you want to do for containers and Kubernetes. And beyond that, we have additional support for open source projects. So while I was saying that for any personal or private projects that you guys want to do, you can work on them in 5-person groups kind of infinitely for free. You get a little bit more if you're doing something with open source. So we've had a contentious relationship with open source, I think decades in the past. Really because for the most part, Microsoft was trying to establish an environment where people would actually pay for software because we wanted to sell them that software. But it's created a little bit of negative, just a little bit of tension between us and some open source communities, which for the most part, I think we've taken great steps to kind of step away from, because we do support open source and we're supporting a lot of communities right now. And we're currently probably the largest contributor to open source on GitHub. Okay, but just in terms of the benefits that you would get, so as an open source project, you're going to get free unlimited build minutes for public projects. You're going to be able to do 10 parallel jobs, and I'm pretty sure you're able to just have unlimited teammates working on one of those projects, so you don't have to worry about additional people joining and suddenly having an additional cost. And in terms of integration, yeah, so we are able to integrate whether it's this pulling in directly to GitHub or vice versa. You'll see Azure Pipelines is available on GitHub, but additionally, GitHub is slowly kind of building their way to be almost an Azure DevOps equivalent. So you'll see GitHub Actions. I think you can jump into the beta right now, but that'll function very similarly to Azure Pipelines, and is just another option for basically doing this. Okay, next we'll do Azure Boards. So Azure Boards, pretty standard Kanban board. You'll be able to select a few different options. So if you want to do something more along the lines of a Scrum methodology or an Agile methodology, we have a couple of presets in there. And beyond the presets, you're able to make edits and really change the information that's available for each of these various tiles that you end up creating. Whether you want to do that, I don't necessarily know. It might be good to just kind of stick with the basics and kind of roll with it. That being said, it is an option. And like I said, this is available if you do have a preference for something else. Like I know Atlassian has Jira, but also I think there was something advertising on the subway recently, like a Monday.com. If you want to use one of those instead of this, there is a toggle. So for any of these services that you see here in basically the sidebar, if you go into project settings, you can just toggle them off, and that one service won't be visible. So nobody's going to accidentally be dealing with tickets in a different board than you're using. Or if you have a new teammate and you tell them, hey, create a repo for this project, they won't suddenly go into repos instead of dealing with your usual GitHub organization. Might have lost. Yep, there we go with repos. So really, functionally, this is going to be the equivalent of just you running a GitHub repo. Once again, the main consideration is that beyond you just integrating a GitHub repo here, which is totally fine and really something you can do pretty easily, is just that there is more support here for Team Foundation version control. So if you're dealing with a company that's coming over from that direction, this might be a better option than GitHub. Beyond that, you've got your test plans. So yeah, in addition to just specifying out the basically details of these manual tests, you'll see kind of the tie-in to how you're able to monitor and get basically data back from everything that's being done. You'll be able to see these little dashboards and have a little bit of information on how everything's basically coming out. Azure artifacts, again, this is for the most part, you're storing the various packages that are dependencies for you, but you also have access to any builds that you've created, and basically you're able to just kind of store this all in a secure place. Okay, I'm gonna jump for a second into, yeah, and the idea is for the most part that you'll be able to mix and match this with whatever you end up needing. So whether you are looking to more so maybe trigger a job in Jenkins, it is an option, and we offer in our pipelines, we offer tie-ins to various services, whether it's running a Terraform script, whether it's interacting with services directly in Azure. It's all kind of available to you to do. I'll jump out for a second. Okay, so if we go to Azure DevOps, this is what it looks like. On the left, you'll have just different organizations that you're able to click into. Here you'll see Microsoft Engineering. So this here is just an individual project that's available under that organization. So if I click in here, I'm able to see, there we go, Azure DevOps. So one of the cool things is that Azure DevOps actually is built on Azure DevOps. So the team that's working on it has a lot of incentive to make sure that there are updates, that any bugs or missing functionality is addressed, because they work on it, and every basically build that they do, every deployment that happens comes from Azure DevOps. Beyond that, you'll see in terms of functionality here. So summary page ends up just being what you saw there, like a little description of the project. So if anyone new on the team is jumping on, they can kind of see what's going on. Beyond that, you've got the option to create dashboards. So you can create custom dashboards, like if you want to do, let's see what's going on in this week, what are the actual tasks that need to be done, what's already been completed. You can pull that up pretty quickly. For the most part, you'll see they have thousands of dashboards, but sure. But you get the option to, oh.
We're running low on time. I just think
Sure,
we
we can.
a minute or two to ask questions if they
Perfect.
have, so we wrap up.
Yeah, so in that case, I mean, for the most part, just clicking through there, this is really just kind of a look at, for the most part, you can create custom metrics. So whether you're looking at, what do we have here? Incomplete asks. So whether you're looking at just highlighting certain work items or highlighting how things are functioning for your team, you have the freedom to do that, whether it's kind of looking at work items with a specific tag to say, oh, this is how different efforts across our team are moving forward. You basically have that freedom to create different metrics with this. Beyond that, for boards, you'll see you've got your little chart of work items. You've got your board, so it all basically follows the format that you saw in the slides. And that's basically, I guess, it for this. I'll show you also in one of my projects, just to, Sure. So here you can see that basically you're not kind of tied to all of the services, and basically if you need to cut one out, or if really you're only looking for a single aspect for a project, you can do that as well, just to not be dealing with basically a larger variety of services than you would need. Yeah, I mean, for the most part, this product is designed to basically cover all the needs you would have as someone that's trying to implement a DevOps process. That being said, if you're using something else that's flexible enough to really be able to integrate with GitHub, to really just kind of cut out any functionality that you don't need. I don't know. Is there anything in here that kind of seems interesting? I know if I were a student, like the fact that it is free for those 5 initial users seems great for kind of early projects. I would also very much encourage all of you guys to take a look at GitHub Actions and start playing around with those. But yeah, I mean, what are you guys thinking?
So we're gonna wrap up. Do we have questions for Patrick before we finish off? Patrick, thank you very much for coming in.
Yeah, thank you.
Appreciate that.